Okay, so in 20.1, number 43, it's true or false. The curl of f crossed with g is the curl of f crossed with the curl of g, where f and g are some vector fields, right? I don't know.
It is the right category, first of all.
Yeah,
Curl is
dude, first things first. Check the category of what you're talking about, right? So like, let's just check. If you take a vector field and cross it with a vector field, one, does that operation even make sense?
Yes.
That's a vector cross a vector, right, in 3 space? Cool, that makes sense. Can I take the curl of that object?
Yes.
Yeah, I think this will be a vector valued function, right? In other words, a vector field. And then I know how to curl vector fields. Okay, so this whole object
Is a vector
is a vector
field.
field. Okay.
Can we still cross vectors and vector fields? Like, is there a difference between those two, or?
Yeah, so what's the difference between a vector field and a vector, basically?
Yeah.
Right.
Like a value function.
A vector field is a vector valued function, right? And a vector is a constant vector valued function.
So it's like a constant versus a function of its own?
Yeah.
Okay.
Right, so vectors are vector fields, they're just really boring ones,
Okay.
right? And you don't always think of them that way, right? Because most of the time, by a vector, you just mean a magnitude and a direction. You don't mean that flow everywhere, right? You could mean that flow everywhere, so the category makes sense, right?
I just want to make sure you could still, like, if you have a vector and a vector field, you could still dot them and cross them and do all those forms. Okay.
Yeah, so those all work. They're the same idea as a constant times a function, right?
Oh. So it's just like vector fields are like 3x, 2y, 1z, where just a vector is 3, 2, 1?
Yeah.
Okay. That makes it a lot.
You guys all good with that? Okay, so over here, I have the curl of a vector field, right? So what kind of thing is that? That's a vector field, right? And over here, I have the curl of another vector field, so that's also a vector field. And then when I cross two vector fields, I think I get a vector field still, right? So, okay, they're both vector fields, right? So at least categorically, there's not an obvious mishmash. Like if I had found out, for instance, if this problem had said true or false, the curl of the cross product is the dot product between the curls,
Yeah.
right? Then I would be like, hey, this thing's a vector field and that thing's not, so we could stop, right? But as it is, I have to do something else. Okay, what else do I have to do?
You have to figure out what these two end up equally.
Yeah, I think maybe we should like
Let's first
calculate maybe just the x components and see.
We probably need some sort of just like set-in function for f and g, just like an f1, f2, f3 or something like that.
Cool, that seems like a great idea. Okay, so let's take the curl of, okay, let me walk over here and be like, okay, I'm just gonna assume that f is f1, comma, f2, comma, f3. What's g?
G1, G2, G3.
G1, G2, G3. I don't know why that became 6. Because they're G's. Okay, so what's F crossed with G then?
So let's see. I need some real. So that'd be
Total pain in the butt, right?
G3.
And then you have to take the curl out.
Okay, so let me take F, cross it with G. I have most of that written right here, right?
Yep.
So I'm just going to go, okay, so that's, cover this guy, right?
F2, G3
F2, G3,
minus
Minus
F3, G2.
F3, G2, comma, and unfortunately I'm going to have to calculate a bunch of these, right? Because I'm going to then take the curl of it. So, on this guy, what do I get? I get,
But
but
backwards
with a
because the
negative sign.
So,
So
it's
it's
F3,
F3 G1 minus F1 G3. Right? Remember there's that minus sign in the or in the cross product formula. And then you get on the last one F1 G2 minus F2 G1. Okay? Nasty pants? Okay? So that's what I'm going to take the curl of here, right? Oh, God.
Find the curl right there.
Cool. Okay, so I need to find the curl of that thing, right? So it's really just a bunch of writing that I have to do. Okay? Okay, so let me just, for simplicity's sake, call this.
H1, H2, H3?
I'm going to call them actually HX, HY, and HZ.
That's good.
Because Ben taught me the cool trick for how to remember how to take a cross or how to take a curl, right?
Yep.
Okay, so
Which would have been easier if F1, F2, F3 were X, Y, Z as well.
yeah, probably. Okay, so in the X slot here, what do I get? I get the partial
HZ,
H. So it goes Z,
Y.
Y,
Y,
X,
X,
then ZYX.
Z, Y, X. And then I need partials. Partial, 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 partial. Those two are too close together. Okay. And there's minus signs, minus signs. Oops, that's not there. There. Okay, and then what are your
First one's X.
partial X? Wait, this is the X slot, right?
Yep.
Y.
So it's
Y.
partial Y.
So that's partial of not Z and not X
So
is with respect to Y. And here this is
Partial Z.
partial Z,
partial Z,
partial Z, partial X, partial
X, partial Y.
X, partial Y. You guys all with that? Okay.
So it's the opposites.
All right. Good. Yes? Okay. Ugh. Gotta just do it though. I just really don't want to. Right? Like, but it's okay. You just do it. So here I'm going to need the two curls and to cross product them, right? So what's the curl of F?
Yeah, it's F3,
Partial
F2, F1, F3, F2, F1.
Okay. F3, F2, F1, F3, F2, F1. Partial, 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 partial. Crap.
Just 3 minus 2.
Using these to separate the components of this vector, because otherwise it's
You got a little too
disaster.
close.
Okay, and we're subtracting, and this is, oh, and good, I did these already. So it's Y, Z, Z, X, X, Y.
I told you.
Right, so I don't need to reinvent that particular wheel, right? And then that exact same thing, but with G's in it, it's going to go right here, yeah? Okay, so I got partial G3 with respect to Y minus the partial of G2 with respect to Z. And again, I'm using dumb notation because I crammed these together too much. Partial G1 with respect to Z minus the partial of G3 with respect to X. And then a partial of F, or shit. G2 with respect to X minus the partial of G1 with respect to Y.
Now we have to cross
Then you
those.
cross product them.
And now we have to cross product those, right?
But it doesn't look like it's.
So at the very least, I can just get one of the components at first, right? Because I feel like this is probably pretty unlikely, right? So let me get the first component out of this cross product and just see if it matches the first component over here.
Okay.
Is all with that? Okay, so what's your first component of your cross product here?
Let's see, it's in parentheses G2, the partial G2 over partial of X minus G1 over
You guys see
Y.
that? Should be this times that
Yeah.
minus this times that. Okay, so I got the partial of f1 with respect to z minus the partial of f3 with respect to x in parentheses times the partial of g2 with respect to x minus the partial of g1 with respect to y, right? And then minus, oh my lord.
When there, can you tell us? Yeah.
From here,
Well, the F1 might cancel out in the subtraction. We still.
It's like
yeah, so I'm looking at this and I'm thinking, hey, the HZ, right, has, oh, that one has an F1 and a G2 in it. Crap. Right? It's possible they could be the same.
that'd be cool.
You guys see that? Like, that would be kind of neat.
Yeah, sure.
So let me see. So I got these, and then what was the second component for this? Or the second part of the X component here?
Oh, it's F2 minus F1 over X and Y. I just assume partials.
So that should be these two, right? So the partial with respect to F2, sorry, the partial of F2 with respect to X minus the partial of F1 with respect to Y multiplied by partial of G1 with respect to Z minus the partial of G3 with respect to X. And then comma other stuff, right? So my goal is just, I need to check, is HZ with respect to Y minus HY with respect to Z what you get when you multiply this crap out. Cool? If it isn't, I can go on with my life and know that this shortcut doesn't exist. If it is, then I'll have to check the other components. Right? Okay, so let's just do that. It's not so bad. We can manage. I need that. Okay, so I need the partial with respect to y of, what was that, hz? So that's this guy. So that's f1 g2 minus f2 g1. And then I need minus the partial with respect to z of the y component, which is f3 g1 minus f1 g3. Cool? Does it feel like there's a lot more stuff down there than there is up here? Uh-huh.
Yeah.
We also have partials in X, unless they all cancel.
Oh yeah. There's partials of x in there. So let's just check and see if one of the partials with respect to x sticks around. Right? Okay, so we need a FOIL, right?
Yeah.
I'm finishing up the foil.
You guys good at foiling?
Yes.
Not necessarily partials.
No, probably not this good at foiling, but
No, partials and across.
So the outer and the last I'm canceling out, which is nice.
no, that's not good. We don't want that.
Wait, no, I did it wrong.
Okay, so foiling, right? So
I
you
did
got
it
the
wrong, sorry.
partial of f1 with respect to z firsts.
I thought I did it good.
Partial of g2 with respect to x. Right, firsts. How do you spell foil?
Outer.
Thanks, sure. So FO is minus the partial with respect to y of g1 and the partial of f1 with respect to z, outsides, insides, is minus the partial of f3 with respect to x times the partial of g2 with respect to x. Right? Cool. And then plus, what do you got? F3 and G1. Partial of F3 with respect to X times the partial of G1 with respect to Y.
Can you like square a partial?
Careful.
Well, it's just a partial.
So what you would like to do, right, it's like, say that this is the partial squared of f1 times g2 with respect to x and y,
That looks like the second partial.
which would be the mixed partial of that function, right?
Yeah.
But this is not that, because the mixed partial of that function probably takes the product rule, and this doesn't. Yeah, so don't collapse your partials. You guys see that? Which actually, by the way, is why it seems like there's not that much stuff over here. But that crap's going to take the product rule. You see that? Okay, so I'm really just hoping that all the partials with respect to x won't cancel, and then I can just stop. So here I got, in the second bit here, I got a minus, and now I'm going to have the partial of f2 with respect to x, and then partial of g1 with respect to z. Okay, so let me see. I need a f2 and a g1, x, and z. And I don't have anywhere up here in f2, right? You guys see that? So this piece ain't going to cancel. It's got an x in it. That stuff doesn't have a partial with respect to x in it.
That's true.
You guys see that? Yes!
Oh,
We broke it.
What does that mean?
they are not equal. This is false.
It's false.
Thank you.
Oh, and I erased the problem a long time ago. Okay, so one way you could think, if you had more tools, that they aren't equal, is the curl's a little bit like a derivative, right?
Yeah.
That kind of makes sense?
No way to change it.
So another way we could have done this is we could have thought a little bit harder instead of going to calculate. But we went to calculate mode too fast because
Oh.
whatever. The curl of f crossed with g, right, is this guy.
Okay.
And I was wondering, is that the curl of f crossed with the curl of g, right? You guys see that?
That would imply that the curve that.
So that's curl
distributes-
squared. That not even. It's just it was more.
Yeah, this seems much more obvious, right? That this shit ain't gonna happen, right? So we demonstrated that by calculating, right? Which was a giant friggin' mess. You guys cool with that? So maybe it would have been nice to think about this. When I looked at this, my initial thought was, a curl's a little bit like a derivative, right? This would be a little bit like not needing the product rule. You guys see that? Right? Like this would be kind of derivative of f times g, right? And the other side of this is derivative of f, derivative of g. Yeah, that's probably not going to happen. The product rule came up for a reason. If this had been true, I would have been kind of surprised, frankly. Cool? Questions, Seals? Might have been easier there. There's some rules that you can, there's some rules for cross products, right? Like at the beginning of the book.
Oh my gosh.
And you could use those rules to simplify this side, and you'll see that you don't get this stuff. Cool, cool?